Students, this is chapter number 7, Wave Optics. We learn some part of this topic in 11th science: reflection of light, refraction of light, then prism, how there is the light is passes through the prism, and related things we studied in the 11th science. Here in this topic we'll study different theories which studied by the scientist about the nature of the light. We know that light travels in a straight line through a uniform and homogeneous medium. The path of the light is called a ray of light. When light comes to an interface, plane surface, which separate the two mediums, the ray of the light is reflected or refracted. A reflection of light and a refraction of light are the properties of the light waves. These briefly we studied in 11th science. Except these properties, some more properties of the light is there, like interference, diffraction, polarization, simultaneous reflection, simultaneous refraction, double reflection, double refraction. These are the various kind of the properties of the light waves. Some properties we will learn here in this chapter. So in introduction we revise the laws of reflection. We already studied in the 11th science syllabus. So the first law is incident ray and a reflected ray on either side of the normal. Incident ray, reflected ray and normal are in the same phase. They are in the same, they are in the same plane, and the important law of reflection is the angle of incidence is equal to the angle of reflection. Similarly, some laws are there with refraction. First two laws are common in the refraction. This is the law, that is a ratio of sine of angle of incidence to the sine of angle of refraction is the refractive index of the medium, second medium with respect to first medium. If air is the first medium and glass is the second medium, then way to write the refractive index, we studied it in 11th science, but this law is known as Snell's law. I repeat, a ratio of sine of angle of incidence to the sine of angle of refraction. It gives us the refractive index of second medium with respect to first medium. Uh, from this law, we'll write n1 sine I1 angle of sine of angle of incidence. N1 is the refractive index of the first medium, and here N2 is the refractive index of the second medium, and sine of angle of reflection. Sorry, sine of angle of refraction has to be considered over here. Then sine of angle of incidence to the sine of angle of refraction, and n2 divided by n1. n2 by n1, that is refractive index of second medium to the refractive index of the first medium. This ratio gives us the refractive index of second medium with respect to first medium. Then this is the introduction of the topic. Then one more important concept is here in this theory of the uh, light, or the nature of the light. Velocity of light is greater in rarer medium than the denser medium. Uh, Now, in this topic, there are the various theories which studied by the different scientists are here, but in reduced syllabus, we have to learn the wave theory of light. Actually, there are the theories uh, of the light, nature of the light is from Newton, then Maxwell, Planck, and Huygens. These are the some scientists, and their study related to the nature of the light is included in the 12th syllabus. But in a reduced syllabus, we have to learn wave theory of light. Uh, According to the Newton's corpuscles theory, the light is in the form of the particles. These particles are emitted from the source of the light. But this particular theory is now not in, we are not discussing over here, because in reduced syllabus, Newton's corpuscles theory is not there. But in our chapter, this theory is there. So we'll go with the nature of the light, and particularly wave theory of the light. Uh, this wave nature is studied by the Dutch scientist Christian Huygens in 1678, and uh, his theory is known as wave theory of the light. He predicted that the light is in the form of the waves, and the Newton, uh, according to the Newton's theory, the light is in the form of the particles. Here some characteristics of the wave theory of the light. First characteristic is material medium is necessary for the propagation of the longitudinal wave through the vacuum. Huygens suggested the existence of an hypothetical medium called luminiferous ether. Uh, Actually, light is the electromagnetic transverse wave. Uh, Foucault is the scientist, and later on he studied the nature of the light and proved that light is not a longitudinal wave, it is uh, a, electromagnetic transverse wave. Electric and magnetic vectors are perpendicular to each other, and these vectors are perpendicular to the direction of the propagation of the wave. Already we studied this vectors in 11th science. Actually, here Huygens suggested uh, a, a different kind of medium for propagation of the light waves, and that medium is the luminiferous ether medium. These are the characteristics of the wave theory of light. What Huygens realized about nature of the light, and the first point is wave is sorry light wave is the longitudinal wave, and it require a different kind of medium for the propagation, and the name of the medium is luminiferous ether medium. Second is the light travels in the form of longitudinal waves, as we discussed in the first point, and which travel with the uniform velocity in uh, homogeneous medium. Uniform velocity is the important words in this second assumption. Then different colors of the light is due to different wavelength of the waves, and when these light waves are enters in our uh, eyes, we get the sensation of the light. These are the certain points which relates to the wave theory of the light, uh, characteristics of the wave theory of light. Some point later on studied by the different scientists, and this theory is corrected. Uh, Merits of this theory is very simple. It could explain the laws of reflection, refraction, interference, and diffraction. Uh, these are the properties of light. Even by using this wave theory of light, we could able to explain the simultaneous reflection and refraction of the light, even double reflection, double refraction of the light. Uh, these kind of properties of the waves can be explained by using wave theory of light. This could not able to explain, these properties could not able to explain by using Newton's corpuscles theory. Now, second merit of this theory, very important merit of the theory is uh, the wave theory of light predicted that speed of the light in an optical denser medium is less than the optically rarer medium. Uh, First experimentally proved by the Foucault. Actually, it is the velocity of or the speed of the light in rarer medium is greater than the denser medium. Uh, uh, Newton is the scientist, and in his theory, he predicted that the velocity of light in denser medium is more uh, to the velocity of light in the rarer medium. This rectified in wave theory of light. Here we have to consider that the speed of the light in rarer medium is greater than the speed of the light in the denser medium. Foucault is the scientist, and he proved with his experimental data. Now the demerits or drawbacks of this theory. First is uh, experimentally proved that light is not a longitudinal wave, it is electromagnetic transverse wave, and there are the electric and the magnetic vectors which are perpendicular to each other, and even they are perpendicular to the direction of the propagation of the wave. This is the drawback. Actually, Huygens considered it is a longitudinal wave, uh, and Foucault is the scientist. He studied that the light is not a longitudinal wave; it is a electromagnetic transverse wave. Then this theory could not able to explain a rectilinear propagation of the light, how the light is uh, transfer or transfer in the medium, how the light is passes through the medium. This is the simple uh, mechanism, but it could not able to explain by this wave theory of light. So it is the drawback of the theory. Then it could not explain the phenomenon. Some properties of the light are there, that is polarization of light, Compton effect, and photoelectric effect. polarization we are going to learn in this chapter only, and Compton effect is not in our syllabus, but photoelectric effect is there in our syllabus. These are the properties of light, and it could not explain by the Huygens with his theory, that is wave theory of light. And the last drawback is the hypothetical ether medium is not exist in nature. Michelson and Morley are the scientists, and they studied while they studied the interference of the light with their uh, experimental setup. uh, they conclude that there is no such medium is available in uh, atmosphere, that is uh, hypothetical ether medium. These are the some drawbacks of the wave theory of light. Question will be on this part. Write the merits of wave theory of light, or they will ask the drawbacks of this theory. Even they will plan the question on the characteristics of uh, the wave theory of light. So this is the only theory, that is nature of light, is included in our syllabus now, in rectified syllabus. So very simple. Now the next part of this chapter is uh, wavefront and wave normal. The question will be on this part is define wavefront, define wave normal, types of the wavefront and types of the wave normal. These things we are going to learn in this topic. Now, S is the source of the light, and we know that the light waves emits in all possible direction. So S is the source of the light. Uh, C is the velocity of light, and for time t, the light waves are travel. Uh, then ct, that is velocity into time, it gives us the distance. If ct is the distance, and source of the light is the center, and if we trace a sphere, it gives us the spherical wavefront. I repeat, here c is the velocity of the light. We know that source of the light, it emits the waves in all possible direction. These are the waves in all possible direction. If for time t, the waves travel ct, that is the product of the velocity and time for which the waves travels, it gives us the distance. Ct as a distance, and S is the source of light as a center. If we trace a sphere, we'll get a spherical wavefront. Okay. So definition of this wavefront, that is spherical wavefront, is locus of all the points of the medium to which wave reaches simultaneously, so that all the points are in the same phase, is called the wavefront. As I said, definition of the wavefront is the important. Then example is uh, light emitted by the bulb in at a finite distance. Uh, on society gate, the lights are there. Bulb is at the center, and the glass surface is the sphere. The waves which is emitted from the bulb is reaches to the uh, outer uh, transparent surface. So this outer transparent surface is the spherical wavefront. Very simple example. Types of the wavefront. There are the three different types of the wavefront. That is spherical wavefront, plane wavefront, and cylindrical wavefront. How this can be explained? Just now, our example is the lamp which is used on the society uh, gate. Bulb and outer surface of dome-like or sphere-like surface is or the spherical surface is our spherical wavefront. Now, one activity is there. Suppose this spherical surface of our society gates lamp is covered with a black surface. Means definitely the light waves will not come out from this black surface. Suppose this black surface is the spherical wavefront. If we cut a, a small part of this blackened surface, then light waves will be come out from that uh, part. So this part is the plane, whole surface is the spherical, but small part of the sphere is the plane. So light waves which is coming from the plane surface is the plane wavefront. And instead of the uh, plane part of small plane part of the uh, spherical surface, if we cut a cylindrical part of the surface, then we'll get the light waves from this cylindrical part, and this is the cylindrical wavefront. So this way you can learn this different kind of wavefronts, that is spherical, plane, and cylindrical wavefront. Explanation of this is not in our book, but types of the wavefronts are there in our syllabus. Then wave normal, simple definition. A perpendicular is drawn to the surface of a wavefront at any point in the direction of the propagation of the light. Simple here diagram, spherical wavefront, source of the light, and in the direction of the propagation of the wave, the normal is drawn to the spherical wavefront. So, according to our definition, perpendicular drawn to the surface of the wavefront at any point in the direction of the propagation of the light. Uh, but here, one important thing has to be uh, keep it in our mind. In case of the spherical wavefront, wave normals are radial. In any direction, if we draw the wave normal to the spherical wavefront, it is radial. And if we consider the plane wavefront, uh, the wave normals to the plane wavefronts are parallel to each other. Sometimes the MCQ or one mark question, that is VSA type question, will be there on this part. So wave normals are radial in the spherical wavefronts, and wave normals are parallel in uh, the plane wavefronts. Now, Huygens principle. Huygens is the scientist who predicted the wave theory of light, and he explains propagation of the light wave when point source of the light creates a disturbance, and this disturbance is passes through the medium. Actually, light is the energy, and uh, this energy is passes through the medium from one place to another place. So this disturbance is propagated through the transparent medium in the form of the waves. How the waves are passes through the medium. This mechanism we studied in the 11th standard. Uh, Oscillatory disturbance passes through the medium without change its form. Actually, this disturbance means the energy is passes through the medium from one place to another place. The same thing is there in terms of the electromagnetic waves. Uh, the light waves has the energy, and this energy is transferred in the form of the waves through the medium. The mechanism we already studied in 11th standard. No need to explain over here. But uh, Huygens principle is different uh, rather than this mechanism of the wave. So we'll go to the statement of the Huygens principle. The first part of the statement is very simple. We know the wavefront, spherical wavefront, plane wavefront, cylindrical wavefront, any kind of wavefront. If we consider every point on the wavefront behaves as a secondary source of the light. On the wavefront, different points are there, means light waves are reaches to the wavefront, and on the wavefront, these light waves or points act as the secondary source of the light, and it start emit the secondary waves in all possible direction. This is the part. Now, these secondary waves are effective in forward direction. With this, you can explain the rectilinear propagation of the wave. And this wave simultaneously uh, reaches to the point because velocity and time for the distance traveled by the waves is same. Uh, at a particular position, the resultant wavefront uh, is given by tangent to these secondary wavelets at that instant. How the uh, wavefront, secondary wavefront will be produced, or how there is the rectilinear propagation of the light is there. It is not explained by the uh, uh, Huygens, but his students explains uh, rectilinear propagation of the light. Major drawback of the uh, theory is Huygens could not able to explain the rectilinear propagation of the light. But here we can explain with the points. Actually, construction of the spherical and the plane wavefront. Actually, it is a secondary spherical wavefront or secondary plane wavefront. So we'll go with the spherical wavefront diagram. Source of the light, and AB is the spherical wavefront. As we uh, studied in our previous part, the light waves from the source of the light will reaches to this. Uh, if v is now here, v is the speed of the light and t is the time for which they travels. Okay, so time of the waves and speed of the waves, product of this will give us the distance, and this vt as a distance, and source as a center. If we trace a sphere, we'll get a spherical wavefront. So part of the spherical wavefront is here, and this wavefront, that is AB, uh, is a primary wavefront. How there is the secondary wavefront uh, produced, we'll learn over here. So here AB is the cross section of the spherical wavefront uh, due to a point source at any instant, and this is a primary wavefront. According to the Huygens wave theory of uh, Huygens principle, the points on this wavefront, every point on this wavefront act as the secondary source of the light, and it emits the secondary waves in forward direction. Suppose this point is on the primary wavefront, it emits the light waves uh, in forward direction according to the Huygens principle. Suppose velocity is v dash, and again time for the waves travels is capital T. Then v dash t is the distance, and this point is the center if we trace a sphere. uh, okay, like that, every point on this wavefront emits the waves. The velocity will be same, and in same time interval they travels a distance. If we trace the spheres, we'll get uh, the spheres like this. Now a tangent is drawn to the all spheres. This tangent is the uh, common tangent. This tangent is the second. This tangent gives us the secondary wavefront. Even we can say the envelope of all the points of these spheres will give us the secondary wavefront. Again, on this secondary wavefronts, all the points are act as the secondary source of the light, and they emit secondary waves in all possible direction. But we consider only in forward direction. So that velocity is v double dash, and time for which the wave travels is t. Again we'll get a new wavefront. Like that, the wave will be, or the light will be propagate in the medium. This is how the secondary wavefront will form. So important article, and the question will be, give the construction of a spherical wavefront or give the construction of the plane wavefront. Here theory in spherical wavefront and plane wavefront is the same, only diagrams are different. Look at the plane wavefront diagram is this in our book. Again AB is the plane wavefront, here a spherical wavefront, and same mechanism we have to explain. Same explanation is over here, only the diagram is different. So no need to explain once again how the plane wavefront is formed. Instead of spherical wavefront, we have to use the words plane wavefront in this. The explanation is same. No need to explain once again how the uh, plane wavefront is formed. So this is the important part of this chapter, and the question will be there on the spherical wavefront or the plane wavefront. We have to draw the diagram. It is for 2 marks. We have to draw the diagram. Diagram is for 1 mark, and you explain the mechanism in a simple way. You will get the marks. Now the next important topic of this chapter is the reflection of light from plane wavefront, plane surface diagram. Plane reflecting surface is Mn, and a plane wavefront AB is obliquely incident on the reflecting surface Mn. This is the diagram. I repeat, plane wavefront AB is obliquely incident on the plane reflecting surface MN. We already studied the reflection of light and refraction of light. Uh, so plane wavefront, and it is bounded by two parallel rays RA and QC are the two parallel rays, and AB is the plane wavefront. It is bounded in these two parallel rays and obliquely incident on the plane surface MN. This is the diagram. Now, mechanism is very simple. AB is the plane wavefront, RA and QC are the parallel rays. Angle of incidence, no need to explain, already we studied angle of incidence in 11th science. Mn is the plane reflecting surface. I is the angle of incidence, that is the angle between incidence ray and the normal, which is here. Okay. Now, mechanism is very simple. Uh, as I said, this AB is obliquely incident on the plane reflecting surface. A will reaches first to the uh, plane surface, and according to the Huygens principle, this becomes the secondary source of the light, and it start to emit the secondary waves in uh, uh, all possible direction. You said in this direction or in the same plane. What I said, A is the point. It is the plane wavefront AB. A will reaches first to the reflecting surface, and according to the Huygens principle, it start to emit the waves in the same medium. B is the point of the wavefront, successively reaches to the point C in time t. It takes time. Obliquely incidence, A will be reaches first and B will be successively reaches to the point C in time t. Here t is 0 and here small t is equal to capital T, you can write. In time capital T, B reaches to the C. The waves which is emitted from this secondary source A will reaches to the point E. This is the very uh, crucial point of this article. I repeat, uh, plane wavefront obliquely incident on the plane surface. A will reaches first. A will act as a secondary source of the light according to the Huygens principle, and it start to emit the waves in the same medium. B will be successively reaches to the point C. It takes time, say capital T. In the same time, the waves which is emitted from this secondary source, that is A, will reaches to the point E. Means point E and point C are in the same phase. And distance traveled by the waves from B to C and A to E will be same. That is AE is equal to BC is confirmed. So this mechanism we have to keep it in our mind, and this shortly I explain over here. You can explain in brief way. Okay, a single point is not here in my explanation. That is, point E and C are in the same phase. Okay, if AE as a distance and a sphere is trace, this sphere is known as homogeneous sphere, and a tangent is drawn to the sphere, that is EC is a tangent. I repeat, the waves which is emitted from A will reaches to the E, uh, velocity is V and time is capital T. If this is the distance and A is the source of the light, if we trace a sphere, this sphere is a homogeneous sphere and tangent is drawn, that is EC, and we have to prove this EC is the refracted wavefront, sorry, reflected wavefront in of the wavefront AB. Now, how to explain it? It is very simple. Now we have two triangles. One is AEC and another triangle is ABC. These are the two triangles, and AC is the common side. Correct? I repeat, which are the two triangles? AEC and ABC. These are the two triangles. Now AC is equal, means common side of the triangles, they must be same. Okay. Now we'll write AE is equal to BC. The waves from A to the E and waves from B to the C in same time reaches to the point E and point C. E and C are in the same phase, means this distance or distance traveled by the waves are same. Therefore, AE is equal to BC and that is equal to VT. V is the velocity of light and T is the time for which the waves travels from B to C, A to E. This is the distance, and we know that this angle, if we uh, draw a parallel line to this, these are the two parallel lines. Okay, and distance between two parallel lines, so perpendicular is here, same way the perpendicular is here, so it is 90. AEC this angle and ABC this angle of the triangle ABC is 90. So two sides and the angle between them or angle is same. So these two triangles, that is AEC and ABC is congruent. Okay. Then we can write the angles of the triangle. Here you can elaborate this, or you can add one or two steps over here. This angle, that is AEC, A sorry EAC, AEC का this angle is 90 minus R. Okay, and ABC triangle ACB angle is 90 minus I. Okay, it's not in my explanation. You write it. This angle, that is EAC, this angle, this is the reflected angle R, and normal PA is normal, so this is 90. So remaining angle, this angle whole, that is EAC, is 90 minus R, and this angle is 90 minus I. Normal, this 90. If this angle is I, this RAM is 90 minus I. So this angle, that is BCA, this angle is 90 minus I, and these angles are equals to each other. Okay, 90 minus R and equals to 90 minus I. 90 get cancels, minus sign on both the side, so you can write I is equal to R. Uh, Remember, the step is not in my explanation, but as I explained, you can add the step over here, that is 90 minus R is equal to 90 minus I. How it is? By using the geometry of their figures. So you can write I is equal to R, and our law is angle of incidence is equal to angle of reflection. So uh, this proves the law of reflection. Therefore, EC is the refracted wavefront of AB, and it is bounded in the parallel rays, that is EA and FC. So this is the uh, explanation of the reflection of the wavefront from plane reflecting surface. So students, uh, actually this part is the simple, if uh, but mechanism is lightly heavy. If we use the uh, geometry of the figure and proved uh, by steps, in steps, so you can write very easily. So we'll stop here, and next time we'll go with uh, the property of light, that is interference and diffraction. Thank you. We'll stop here.